How do you feel about bell work? We good? Okay, cool. So, this is just a little practice from yesterday, what we worked on yesterday. Just filling in the table and then graphing it. So, 3x plus 1 to the 1.5. Where should we start? Like what x's should we choose? I don't know if we got to this yesterday. Do you guys remember how you chose your x's with root functions? What number or what part of the equation helped you choose it? Bless you. Okay, so it's technically our h value. Do we have an h value in this equation? No, right? So we can just choose 0. Okay, and then we go up 2 from there, down 2 from there, okay? All right, so if I plug in, everyone got calculators for the most part, cool. If I plug in -2, I'm gonna get 3, -2 plus 1/2. What do we get? You plug it in your calculator. Three to the -2nd power does what first? Fraction, yes. So this will become 1 to the 9th, right? Plus 1/2. So if you plug that in your calculator, what do you get as a decimal? Yep, 1.61. And then same thing with -1. This is also the same as 1/3 plus 1/2. What do you get? Anyone got anything? Do you have it, Ryan? Yeah. 1/3. Don't forget to add the 1/2 to it. Should be 1.83. Okay? Let me plug in 0. What do you get? It's also the same as 1 plus 1/2. 2/2, yep. If we plug in first power, that's 3 plus 1/2. Get 4/2. And then if we plug in 2, we get 9 plus 1/2, which you get 10.5. Okay? And now that we have our x's and y's, we can plug them in to the graph. So sometimes it's really easy just to start with our y-intercept. So 0, 2.5. It's going to be right about here. And then we've got 1, 4.5. And then 2, 10.5, which is right about at the very top of the graph. And then we got -1, 1.83, just like right there. And then -2, 1.61, just right there. Where is our asymptote at? Anyone have a guess? We also might not about touch that on this class. That's my fault. Our asymptote is 1.5, okay? So our asymptote is going to be like right here. So we cannot touch or go past this wall, right? So our graph is going to look like this. All right? Everyone got on bell work on this practice? Can I change pages, or do you guys still need this? You good? Okay, cool. All right, so we didn't get to finish this practice problem from yesterday, so we're going to finish this first, and then we'll move on to the new material for today. So if you flip back to, what was it, page 378? It's where we put those sticky note graphs. It's where we put those sticky note graphs. And the graph that you didn't get to use, that's what we're going to use. That's what you're going to use for this one today, okay? So, our equation is 4 to the x plus 1 minus 5. The fun thing about this one is that this is actually a homework problem. So if you do it in class with us, then you've got a homework problem already done. Or at least to look at. So you can put it in McGraw-Hill later today. Okay, so 4 to the x plus 1 minus 5. What is our a, h, and k values? A is not 4. 4 is our base value. What technically is in front of 4? 1. Yep. A is 1, so A doesn't really matter because it's not affecting our graph at all. 370 or 388? No. One of these graphs. Okay. What is our H value? We were on 358. 358, sorry. Yeah, sorry, I think I told you guys the wrong number. What's our H value? 1. No, just 1. Not x plus 1. Remember yesterday? Oh, sorry. Our standard form is f of x equals a times bx minus h plus k. So x minus h, and in this sense we have x plus 1. So h is what? How do we get a positive from a negative? Yeah, a negative plus a negative equals a positive. So yes, so this will be a negative 1. Okay? Or not a negative plus a negative equals a positive. I mean to say that I don't know what I'm trying to say. That was confusing. K value. Not negative. Oh, yeah, negative 5. Sorry. I'm thinking 1.5 from our fellow problem. Yep, negative 5. Perfect. It's right there. Okay, so we just talked about this in the bell work. How do we choose our x values to plug in? What value do we use? Our x. It's from our a, h, and k. We choose one of those values, and it helps us know what x values to use. If you look back at your bell work, we started with 0. What value was 0? A, h, or k? H. Yeah. We start with their h values to plug in. So we start with -1. And then we go up from there. And then we go down 2 from there. Okay? So we can start plugging these in then. And we get 4, -3, plus 1, minus 5. 4 to the -3rd plus 1. -3 plus 1 is? What's -3 plus 1? -2. So we have 4 to the -2nd power plus or minus 5. When you plug that in your calculator, you should get something like -4.9375. Okay? Alrighty. And then when we plug in -2, we get 4, -2 plus 1 minus 5. 4 to the -2 plus 1 is 4 to -1 minus 5, which is 1/4 minus 5, which you should get something like -4.75 when you plug it in the calculator, okay? And then we can do 4 to the -1 plus 1 minus 5. What is -1 plus 1? 0. 4 to the 0th power is what? Anything to the 0 power is? 0, 1. There we go. Yep. 1 minus 5 is? Not just 4, but -4. There we go. All right. And then 4, 0 plus 1, minus 5. So we get 4 to the 1st minus 5. What's 4 to the 1st minus 5? Four to the 1st is 4. 4 minus 5 is -1. And then we got 4, 1 plus 1 minus 5. That's just 4 to the 2nd minus 5. What's 4 to the 2nd? 16 minus 5 is 11. Beautiful. All right. And then we go and plug these points in. So we've got 0, -1. I'm going to go right here. Then we've got 1, 11, which is going to be like right up at the tail of that A up there, if we were to plot it. And then -1, -4. And then -2, 4 3/4. And then -3, -4.9. It's like right there on the edge. So when we graph this, what do you guys notice about where our asymptote is? Where's our asymptote at? 4.9. Not -4.9. It's going to be approaching something a little bit larger than that. Because if we were to continue plugging in negative values of x, we're going to get closer and closer to the next number. What comes right after like -4.9? A whole number. -5. What do you guys notice about our equation and -5? -5 is our what value? Our k value. So, what this shows us is that our k value is our asymptote, okay? So this kind of makes it a little bit easier when we're looking at our equations and we don't know how to find our asymptote just off of the graph. We can just look at the equation and say, okay, what's our k value? So this last one, 1.5, 1.5 was our k value. So 1.5 was our asymptote. Do you guys see that? Is that making sense? Just like H is a good place for us to always start our x values, to plotting our x values, K is helpful when it comes to our asymptote, okay? So that's what we really wanted you guys to figure out with this specific practice, okay? So, good job. Okay, you guys are going to flip to page 259, if you're not already there, sort of. Today we're talking about exponential decay. So yesterday we talked about exponential growth. This is when we like to call this an up sloping or up trending graph. So if you look at the one we just worked on, it's going up. So as x approaches infinity, f of x is approaching infinity, okay? With decay graphs, which we'll see in a second, it's going to be a little bit different, okay? So the formal definition is this occurs when an initial amount decreases by the same percentage over a given period of time. The key thing to note here, that this is when b is between 0 and 1. So let me write out our standard form again. Our standard form was f of x equals a times b, x minus h plus k, right? So this is saying that an exponential decay happens when b, so this value right here, b, is between 0 and 1. So that's saying that if b is less than 1 but greater than 0, that's when we know we have an exponential decay function. Okay? So the first activity or first example of exponential decay, which is example 5, because this is still part of 7-1, we're kind of determining whether when we look at these functions we're given, is it exponential decay or is it exponential growth? So if we know that exponential decay is when b is between 1 and 0, what do we know b has to be for an exponential growth? It can't be between 0 and 1 because that's exponential decay. What do you notice about our b values in our practice we just did and our bell work we did? Yeah, they have to be greater than 1. So we know for exponential growth, b is greater than 1, okay? Okay? Does that make sense? So, anyone have questions? Everyone feeling kind of okay about this? We're going to do some practice, so it'll help. Okay. So the first one, we're given f of x equals 5 to the x. Because 5 is what than 1? Is it greater or is it less than 1? Greater. It is greater than 1. F of x is an exponential growth or decay? Growth. Yes. Exponential growth function. Good. Okay. So for b, g of x equals 2/7 to the x power. Is 2 to the 7th greater than 0 or less than 0? Greater than 0. And then is it greater or less than 1? less than 1. So we know that this is a what exponential function? Growth or decay? Decay. All right. H of x equals 4/3 dx. Because 4/3 is what then 1? Is it greater than or less than? It's 4/3. If we were to write that as a mixed number, what would we have? 4/3 is the same as 1n. If you like type it in your calculator, what's 4 divided by 3? Yeah, it's greater than 1.3-ish is for 4/3, because 4/3 is also the same as 1 and 1/3, or you can say this is 1.33 repeating. Okay, so 4/3 is greater than 1. So is it exponential growth or decay? Growth. All right. 1.05 to the x power. Is 1.05 greater than or less than 1? Greater than. Growth or decay? Growth. And 0.85, is it greater than 0 or less than 0? Greater than? Is it greater than or less than 1? Less than. So do we have growth or decay? Decay. Good. Are we feeling okay about this? If you were given this on your homework, you would be able to do this? Yes or no? Good. Okay. Can I move on from this page, or are you guys still writing? Everyone good? Cool. All right. This is our last example of today. We're just going to work through example 6 and 7 real quick. So example 6, we're just looking at domain, range, y-intercept, asymptotes, all of that. So looking at our 1/2 x. So remember when we talked about parent functions yesterday? Our parent functions for exponential growth looked like 2x, 3 to the x, 4 to the x, so on and so forth. Those are exponential growth. With our exponential decay, there's always going to be a fraction as our b term. So this is actually one of our parent functions. This is the parent function for the 1/2 to the x, okay? So anything that has a b value of 1/2, you're always going to want to look back at this graph to see how it transformed, okay? What is our domain? Domain is our x's or y's? It's our x's, right? So where is it when you're looking at where is it going in the x's? Where is it going? Think about how if I were to keep going towards negative x's, where am I going? Like, am I going to keep going towards that negative x's? Is that possible? Yes. Is it possible for it to keep going towards positive x's? Where is it going? Yeah, it is, but where is it kind of approaching? Sorry, I'm getting my range and domain mixed up. Where is it going in your positive x direction? It's going to keep going towards positive infinity. Yep. So our domain is our all reals, okay? Which you can write as negative infinity to positive infinity, or you can write as the fancy R. Okay? So that's kind of the fun thing about exponential growth and exponential decay. They both have all reals for domain. And our ranges are going to be very similar to like what we had yesterday. Okay? As we go from our range, what are we looking at? We're looking at our y's, right? What is the smallest y we can go in this graph? Smallest y value. Not 1, much smaller than that. What are we approaching as y goes this way? What are we approaching? Negative infinity, but we have a wall there. Do you see what the wall is? What's our asymptote?
Oh, it's 0.
It's 0, yeah. Our asymptote is 0. What value do you look at to find your asymptote again? AH or K? K. We always look at our K value. So we know our asymptote is 0, therefore, in our range, we start at 0. And as y gets larger this way, what are we approaching? Infinity. Yep. So just like yesterday with our range we had with exponential growth functions, same thing with exponential decay. Okay? What's our y-intercept? 0, 1. Yep. Okay? And then end behavior, just to touch on it. As x approaches infinity, what is f of x approaching? Infinity. Or no, wait, sorry. As x approaches infinity, which means we're going this way. We're going towards positive infinity with our x's. Where is y approaching? What's that line keep continuing getting closer to? 0. Do you guys see this? As this line continues on towards positive x's, it's going to keep getting closer to 0, which is that black line I just drew. Okay? Does that make sense? More confusing? Okay. So as x approaches infinity, f of x approaches 0. As x approaches negative infinity, f of x approaches what? So as x goes this way, that big black arrow is, what are we approaching? And our y's. Yeah, negative infinity. Or not negative infinity, yeah. It's going towards infinity. Do you see that? As x continues on towards our negative infinity, y is going to continue reaching towards positive infinity. Okay? That's not what I wanted. Okay. Everyone feel okay about this? You're gonna have more practice in your homework, so. Alright. We're gonna look at a transformation of an exponential decay, and this is our last thing we're gonna do today. What is our AH and K value? What's our A value? -2. All right. That means we reflect across the what? that were reflected across. What did we reflect across yesterday with A? When A was negative, we reflect across X. Yes, x-axis. All right. Do we stretch or compress? Stretch, yes. 2 is greater than 1, so we stretch. All right, what's our H value? 4, yep. H is 4, that means we translate how many units which way? 4 to the right, yep. H deals with our X direction. And then what's our K value? 3. So we translate how many units where? 3 up, yep. Because it is positive, which means we're going to go up. Okay. G of X, or I meant to say that, so let's say F of X, is a transformation. So this function is a transformation of what would our parent function be? If you guys remember, parent function is always our f of x equals b to the x. What's our b value in this equation? What's our b value? What's our parent function for this? Yeah, 1/4. That's written really badly. 1/4 to the x is what we transformed from, okay? Does that make sense? So the easy way to be able to tell where our b is, we know that this is A, this is H, and this is K. There's only one number left to look at, and that's 1/4, okay? So, all right, everyone feeling okay about this? You guys have 6 minutes to work on your homework. So here's your homework pages again. Fun thing, we already did number 7, so that is already done for you. So yeah. Test is still going to be in 2 weeks from now. We're still figuring out what day we want to do it on, but we'll let you know. So yeah, if you have any questions, let us know. But you guys have time to work on your homework. So.